This is a Pye TRS-2000 AM FM stereo radio. There's not many of these about from what I can see. Anyhow, the reason you're looking at it here at the moment in its very disassembled state is it's one of the radios I've come across that has a what to me is a bad problem on AM. And I've come across a few radios that have this problem over the years. What the problem is that on heavily modulated bass on AM, which you'll get in music, the detector distorts, but it doesn't distort on higher frequency audio information, as if the bypassing on the AGC line isn't adequate. So I was able to fix another radio that had this problem by altering the AGC capacitors, increasing them in size, and that got rid of this phenomenon. Now I can demonstrate the effect here of increasing that capacitance by holding a capacitor across the appropriate pin on the IC, which does all the AM FM section, and letting you have a look on the Crow and having a listen to the difference. And I'm modulating a signal generator with audio or sine wave below 100 Hertz. This is where the problem becomes particularly evident. Anyway, just hang on and I'll show you the setup. Alright, so the audio signal generator is up there on the left and the RF signal generator on the right of the Crow, and I'm modulating probably a little bit over 50%, a roughly 650 kilohertz signal with 70 hertz audio at the moment, and you can hear the distortion in it, and you can see the distortion in it. That waveform is what's coming out of the audio amp across one of the speakers. Now if I go into XY mode, I love XY mode on oscilloscopes because it gives you a very good comparison between two things, apart from it being off the screen. That's the waveform of the audio which is modulating the signal generator on the X plates and the output of the radio on the Y plates, and it's nothing like a straight line, and it's not a very good ellipse either. If I go up to say 100 Hertz, we're getting back to something more ellipsoid. 200 Hertz, it's more like what you'd expect, and of course kilohertz. Crackle, crackle. Anyway, so there's obviously a phase difference in those waveforms, but no distortion. And there's not much of a phase difference here either. That's 300 Hertz, by the way. But if we go below 200, we'll go up the other way. Ooh, interesting things happening there. There's 200 again, 150, 100, and then some horrible things start to happen to the waveform. If you were to look at the direct waveform across the output, that's 100 Hertz. Apart from the amplitude dropping, the shape gets pretty horrible too. Very nasty around there. So, just hang on a second and I'll show you what the bypass capacitor being increased does. I've just got to move the camera. Alright, we'll give this a go trying to show you here. It's really awkward trying to get the light into the radio where the IC is, which it's pin 8 I'm looking for. This is a TDA1220, by the way. So pin 8 is the AGC pin. So listen carefully and have a look at the waveform. Now if I reduce the amount of RF from the signal generator, and I mean it's only capacitively coupled, apart from all the noise comes up, which is a lot of that's from the light. You can hear and hopefully see the distortion's not quite so bad. So this only happens with carriers that are fairly strong radio stations that have got quite heavily modulated bass in the audio. If I was to decrease the amount of modulation, that's probably only 20 or 30%. The second harmonic, which is primarily the type of distortion it is, isn't anywhere near as strong now, but as it gets quite bad. But that's 100 Hertz and up, and although it's not a sine wave, it's a lot better than further down. That's 150 there. And we'll go down to 50, increase the modulation, and it's awful, absolutely awful. So if I put the RF up again and put this across, and even at that level of modulation it's not getting rid of all of it, but it's certainly an improvement. That's without it. Increase it again. Right, so as you can see, when you get low enough in frequency, and that's 50 Hertz, it doesn't remove it completely, but it certainly makes a big difference. And it's only on really strong signals that it can't remove it. So there's obviously a distortion that is coming in that's frequency dependent on the audio, and that is coming back to the bypassing problem. Either the electrolytic capacitor down here, one of these, I'm just about to disassemble it and find out which one, is drying up because the radio is certainly old enough, probably from the 80s or 90s, this radio, or it just wasn't big enough in the first place. I've come across some AM radios that have this problem when they're brand new, which is pretty terrible, because just because AM might be the poor cousin of FM in some receivers, many receivers actually, it doesn't mean that it should be as bad as it is in some. And some of them are good brands that should know better too. Alright, so I'll disassemble the radio so that I can get to that capacitor, remove it and see what's happened to it, and put the test one in that I've been using, which is, by the way, a 22 microfarad, and we'll see what the difference is and come back. Alright, that's 75 Hertz with no bypass capacitor at all. Matter of fact, at 400 Hertz you might be able to hear it sounds awful. So even at high frequencies with no bypassing, it sounds terrible. So if I can get to the contact. Right, as you can hear, that's somewhat subdued. So we'll go back down to the next range. And these are only about 3-inch speakers here, so we're on 80 Hertz at the moment. Tilt the camera up a bit. There we go. Let's see that. Get the light out of that. Looks alright. $45, 50 Hertz, 55, 60. Bring the signal levels up. So it's not bad. Now if I was to get rid of that's the 22. that's what it's like with none. I think the IC is getting a bit unstable. Whoop. That's what touching pin 7 does. It's very hard to get to. There we go. So, it's not quite as good. That's 10. And this is 22. So I can do with 22. Now this is the original 10. Sorry for the hands and the field of view there. I don't know, unless I turn this thing upside down, if I can even get the original one on there, because the leads are so short. If I turn the thing upside down, I'll put the camera on it so if it blows up you can watch. There we go, I think pin 8's up there. Oh no, I'll put some light on it. Alright, so that's... quite, isn't it? Alright. So that's the original 10 microfarad. This is a replacement 10 microfarad. And this is a 22 microfarad, which is the best of the lot. So without even testing it, I don't think... Oh, that sounds awful. Let's turn down. I don't think the original 10 microfarad is completely kaput. Right, we're back again. Oh, it doesn't like that fluorescent light, does it? At 75 Hertz, at about 60% modulation, and a strong signal, and it's not overloading, and that's what running down and up sounds like. And it's not really bad until you get around 50 Hertz, but that's a really strong signal. If you drop the modulation percentage a bit, it's not bad. So I think that'll do. So I'll let you hear what it sounds like with a bit of audio of the music type on it. There's a bit of audio from it. That's the signal generator being modulated by an FM station, because it's really hard to get an AM station playing music, at least a strong one, when you need one. So that's why I'm giving this alternative arrangement.
All that I have is all that you've given me.
And this is a really great excuse for having a incandescent light, or maybe an LED light rather than a fluorescent light, near an AM radio with all the noise it picks up. But anyway, you can hear that it's reasonably clean, clear bass audio in this radio on AM now. If you've had this sort of problem before, had to fix it, come across any alternative solutions, found the reason why they make these ICs which are particularly sensitive to whatever capacitors on their AGC line, when other radios completely free from it, or seem to be completely free from it. Some of them are using bipolar transistor IFs and some of them are using IC IFs. I don't know, but this is one of three, actually one of 4 types of radio I've come across that do this on AM. So please let me know. Hope you enjoyed the video. All the best. Bye for now.